In this episode, I'm building my TrueNAS Home Server using some old gear and a brand new 4-drive network storage chassis. What you need for this build are network storage chassis, mini ITX motherboard, power supply unit, hard drives or solid-state storage devices. Are you ready? Let's begin the build series. I've already installed the motherboard and power supply into the network storage chassis. Now I remove the drive caddies by lifting the handle and pulling them out. Next, I am going to place the hard drives onto the caddy and screw it in securely. 2 screws on the diagonal sides should do the trick. I've these 3 TB Western Digital drives since 2013 for my first NAS storage running FreeNAS. Since they are 8 years old mechanical drives, and to be on the safe side, I've used Crystal Disk Info tool to confirm that they are still in good working conditions to store my precious personal data. Once we have secured all 4 hard drives onto the caddies, insert them into the chassis by pushing them in all the way, and then press down the handle to lock it in. There is hardly any maintenance needed on this home NAS server on the hardware side unless there is a possible failure on any component. The most important component is the data, and we are protecting it using ZFS RAID Z. We'll discuss this topic in another video. This motherboard has 1 gigabit network port, and I'm using a USB drive as the TrueNAS boot drive. There are a number of USB ports to connect to external USB storage too. Here is the 1U power supply unit with an exhaust fan, and the chassis exhaust fan shall keep our hard disks and motherboard running cool. I will now briefly walk through the hardware components and where to get them. Starting with the network storage chassis, I usually searched on online stores like AliExpress, Amazon, Shopee and Lazada to find the most suitable unit at the best price. I found this NAS chassis from AliExpress. What I like about this unit is its compactness and the drive caddy layout. It supports 4 drive bays, a mini ITX motherboard and a 1U power supply unit. However, there is no expansion slot for any PCI or PCI Express add-in expansion card. So we just need to make sure what we needed are already on the motherboard. Next comes the motherboard. This is what I am using, ASRock N3150 IDX. It comes with Intel quad-core N3150 without hyper-threading, 2 SODIMM DDR3 memory slots supporting up to 16 GB for SATA 3 ports, integrated graphics, USB 3 ports and 1 gigabit network port. Also, it has mini PCI Express and 1 PCI Express 2.0x1. Power supply is one of the critical component for always-on and critical systems. FSP is a well-known brand and I've good experience with it too. For this NAS build, the peak power consumption during drive spin-up is about 100 to 120 watts, so this 200 watt rated power will be more than sufficient. The second consideration is the type and number of power connectors. The usual suspects are 24P for the motherboard, 4P for CPU, and good for up to 65 watt processors. 7P SATA for disk drives and 5P for all other peripherals. The final major decision is the choice of storage devices. Would it be mechanical hard drives or solid state? As I have a number of 3 TB hard drives which are still in good working conditions, I'll be using 4 of them for a total of 12 TB raw capacity. In the future, we could replace them with higher capacity hard drives for more storage or solid state devices for better performance. The next stage is to download TrueNAS Core software, write it onto a USB drive, and install TrueNAS Core onto your network storage server. TrueNAS Core is the world's #1 NAS operating system, free to download and use, and it is also community supported. Moreover, it is also very easy to install and configure for first-time users. As of this recording, the current version of TrueNAS Core is 12.0 U6, and it is about 918 megabytes in size. I am using Rufus to write this ISO file onto the USB drive here. I'll leave a link to Rufus and other tools I use for this build series. After the USB drive is ready, insert it into any USB port on the network storage server, and set the motherboard BIOS to boot from this USB drive. Follow the instructions and let TrueNAS software installs onto the hardware. When TrueNAS is successfully installed, you will see the console with the network IP address. Use your root account and password to log into the console. On your browser, go to your TrueNAS web console IP address. Enter root as username and the password you set during the installation. For first-time users, I have these quick tips for setting up TrueNAS to work in your home environment for Windows SMB file sharing. Step 1 is to set the TrueNAS to the proper time zone. For me, this is Asia/Singapore. Click Save to confirm the change. Step 2 is to verify that all the drives are properly detected and create the storage pool with the right data protection level. TrueNAS uses ZFS data storage pools to efficiently store and protect data. In the Create Pool screen, give it a pool name and assign the drives as DataDevs and set the data protection level to RAID Z. The estimated raw capacity will be reflected accordingly. I'll be covering the various forms of data protection level in my next video. Subscribe now and click on the notification bell to be notified when my new video is posted. Step 3 is to add a dataset to the pool I've created. A TrueNAS dataset is a file system that contains files, directories, and have individual permissions or flags just like your C drive or D drive. Give it a dataset name and click Submit. It's that easy. Step 4 is to create TrueNAS account group and user that have permissions to the dataset. I'll create a group named Family and click Submit. I'll also create a user named Steve, set my password, and associate it to the group named Family. Step 5 is to set the owner and group permissions to the dataset. This would later allow the user Steve to access the file share. Step 6 is to make your dataset visible to your Windows network. I'm adding SMB share, also known as CIFS, for my Windows network. Now your SMB share is set up. Step 7 is to verify the above steps are done correctly. I'll attempt to access the TrueNAS via my account credentials. If this is successful, I'll be able to see the pool named Pool 8TB. Great, my credentials work as planned. I'm going to map this network drive as a drive letter for ease of future usage. My usual test plan is to create, read, update, and delete both files and directories to ensure all permissions are correct before long-term use. So far so good. My final test is about performance. I'll copy a large amount of data, about 52 gigabytes, to see if I could get a consistent network performance writing to the NAS dataset. Since this motherboard has only a gigabit network port, it should be able to deliver about 100 megabytes per second. Wow, it's getting above 100 megabytes per second consistently for about 8 minutes. All good and ready for long-term usage. With the TrueNAS Home Server project a success, I'll briefly talk about how to monitor the TrueNAS server. My first touch point will be the TrueNAS dashboard. This gives me a good sense of where the potential performance bottlenecks would be. These are the 4 key metrics: CPU, memory, storage pool, and network interface. First thing first, my intent for this TrueNAS server is to store and share my personal data with my family, so this cost-effective setup should suffice. For higher performance expectations, one should upgrade the network interface to 2.5 gigabits per second or 10 gigabits per second and also a compatible network switch. If you are planning to host applications on this TrueNAS server, having more CPU cores and threads, more memory would be necessary considerations. Also, consider adding NVMe SSDs as cache or DataDevs to improve data access performance too. Hope you have a great learning experience in this video. If you have any questions, do pen down your comments, and I'll try my best to share my experience and knowledge. Also, I'll be releasing videos on a weekly basis. The topics include ZFS, crypto mining, investing into cryptocurrencies, etc. Thank you for spending your time with me and see you in my next video.